Hello and welcome to today's webinar, Accelerated Unit Testing with IAR Embedded Workbench and Cantata for Safety Critical Systems. I'm your host, Georgette Callas. Our presenters today are Adam Mackay, Integrations Manager at QA Systems, and Rafael Taubinger, Global FAE Manager at IAR Systems. Please note that you'll be muted throughout our presentation. If you have questions, please feel free to type them into the question window, and we will answer them during the Q&A portion after the demonstration. If you miss any part of the presentation today, a recording will be sent to you after the presentation. This is our agenda for today's session. As you can see, the agenda will be split between IAR systems and QA systems. We'll start off with an introduction of IAR systems and explore the IAR Embedded Workbench, that is one of the world's most widely used embedded development tools. Additionally, you will learn how to speed your path to certification with the certified build chain from IAR systems, and also the importance of code quality. Finally, there'll be a practical demo with all the mentioned tools. We will then look at how to build up a dynamic test suite on your project. We will explore some of the powerful features of Cantata to help make the unit and integration testing process fast and flexible. In the demonstration part, we will show how quickly you can build a test suite from scratch using IAR Embedded Workbench project as a starting point. And with that, I'm going to hand over to Rafael.
Thank you, Georgette. So, IAR systems. So, some of you might already be familiar with IAR systems and our main product, that it's the IAR Embedded Workbench. We proudly like to emphasize that it's the world's most widely used embedded development tool. And it's of course more than ordinary toolbox that it's available for you. And I will quickly give you a quick overview what we can of course offer you. It starts with debugging and trace probes. I mean, you need to have access to hardware to get your application to running in Target 2 after all the testing and making sure everything works fine. On top, of course, when we talk about debugging, we will explore that a bit more. The simulator also makes a huge difference when you are doing testing. But also very important on the day by day, you need to make sure about the code quality in your application. So you have static code analysis and also runtime analysis being part of your day by day to make it easy and accessible. And from our build chain, I mean the compiler, the linker, the libraries, we have the certified edition. That's of course the main topic here today. So whatever industry you are working with, industrial, automotive, railway, medical, there is of course a solution for you. And more and more important, all the effort you spend by developing or the core competence of your company, you probably need to protect that. Security legislation, it's becoming stronger and stronger, and IP protection and production control is also of course part of the solution. And finally, very, very important, I mean, it's professional tools, but at the same time, there is someone to always help you. So we are really proud of the global technical support that you have access. So this is IAR systems with IAR Embedded Workbench, where we can help you. And now I'm giving it over to Adam from here.
Thanks, Rafael, and hi everyone. Rafael, are you able to? That's great. So this is a great graphic to start any presentation. This isn't computer generated. This is the actual race car driven by our CEO when he's out of the office. QA Systems, we're known for helping customers with testing and verification in the embedded software space. We've a range of tools to help you achieve certification to industry-specific software standards. The parallels between racing and software development may not be immediately obvious. However, both require the design and implementation of solid processes and rigorous testing to ensure success. These two elements, solid processes and rigorous testing, run through all of our work at QA Systems. We work with customers throughout all safety critical industries, including automotive, defense, aerospace, industrial automation, medical and beyond. Basically customers who work towards compliance with standards such as ISO 26262, DO178C, IEC 61508 and so on. Recently, we've been working closely with IAR to enhance the developed test experience for our mutual customers, and it's great to see so many of them able to attend this presentation today. So, on our journey to successful compliance, testing tools need to address several key challenges. In the upcoming product demonstration, I'll work with some typical C code to build a test harness in real time, starting with an IAR Embedded Workbench project. In particular, I'll show how Cantata can quickly produce a useful testing framework from scratch using its powerful integration, automation, code coverage, and cool interface control features. We'll also take a look at the reports that can be produced to submit as certification evidence for your project. But first, I'll hand back to Rafael, who will walk you through some of the more detailed features of IAR Embedded Workbench.
Thank you, Adam. So I briefly already mentioned IAR Embedded Workbench, but if we go and look a bit inside what's in our toolbox, of course it's separated in different components. I mean, we have the IDE itself with the editor, with the project manager, library tools, but then the build tools, that's mainly the core of our tool, our own technology, the compiler, assembler, linker. But also very important is the debugging part, and for that we of course have our own debugger that we name IAR CSpy, where we have of course hardware support, but that means different debugging probes, but also very important we have the simulator that can be very, very useful when doing unit testing, and Adam will later cover that in detail. So we want to cover a bit more the certification, the functional safety part. So are there ways to speeding the path to certification? The answer is of course yes. So mainly what happens is that as I mentioned initially, there is a certified toolchain from IAR that you can make use. So as you can see, the certified version by TÜV SÜD, it's a special version. We also like to say that it's of course a frozen version, and it can be used for of course any safety critical application. I mean, starting from industrial, the IEC 61508, if you are developing in an automotive, the ISO 26262, maybe also railway, the 50128, and finally IEC 62304, that's the medical standard. And you might be familiar with most of the standards. There are different, of course, safety integrity levels, like IEC 61508 goes from SIL 1 to 4, 4 being the highest level. And similarly, ISO 26262 for automotive, it goes from A SIL A till D. Mainly where I want to come here is that starting from, for example, SIL 2, it's highly recommended to use certified tool chains. And definitely, of course, the tool, it's certified, it's a frozen version, but you get way more on top of it. So you'll mainly get access to a simplified validation, because yes, the certificate, it's important, that's part of the package. But also very, very important is that you get a safety report, and you get regular reports from us on known problems too. And what will really help you is what we always like to talk about. It's the safety guide. Mainly the safety guide will tell you how we can advise you, recommend that you use the tool, starting from settings, libraries, how to isolate them if you need to use these certain libraries, or libraries that are maybe not recommended or are not safe libraries. So this is all covered in the safety guide. So that is a very valuable reference for you when starting your safety critical application. But on top, what it's also important to mention is that you get high priority support. So if you send a request into IAR, you always got on top of the queue, so you'll get quickest access to getting a reply and help. And as I mentioned before, it's a frozen version, and we let customers know about the regular reports if there is any known problem that pops up in the field. And if, of course, needed, there will be validated service packs that are also certified. So mainly what that means is that you can focus on your code, on your application, on the testing, on the reports that you need to generate, and we will take care of the tool chain because you have access to the functional safety edition of IAR. Finally, what I can also mention here, this certified toolchain, it's available for ARM, for the Renesas architectures like RX, RL78, and RH850, but also for STM8. Next slide gives you a better overview on what we currently support, or what standards. Mainly it's all of them. Just on Renesas RH850, that's of course derived from IEC 61508. That's the umbrella standard, but on the upcoming version that will be part 2, so it will all be fully covered. To give you a better picture on what it means, the certified toolchain, you have to imagine that we have the standard version that gets updates. Of course, new features being added, new devices being added, but we end up certifying new versions mainly every 12 to 18 months. So that means that that version gets frozen, and it becomes mainly a new product that gets its own life. And what I can tell you is that as long as you have what we call a support and update agreement, that version will be maintained. So there is no limit on time for you to get access to it. And of course, if there are bugs, certified packs will be released, but just to show you the value of having access to a frozen version. So you don't need to repeat all the tests or certification steps or matters with the entity that it's doing the certification for you. So that makes a huge difference for you. But also very important, and what we always like to tell our customers is that yes, we are talking about safety, but of course safety starts with code quality, and there are many standards, or let's say best practices available nowadays. Some of them are kind of mandatory. For example, if we mention MISRA C, you're probably familiar with it. but there are, of course, some other variants. I mean, MISR-C from the Motor Industry Software Reliability Association. There are different editions, but what you should be aware is that if you look on IEC 61508, mainly it's highly recommended, or that you should adopt, let's say, some tool that can help you to enforce the coding standards. And of course, there is MISR-C 2012, 2004, even MISR-C++ 2008. So with, of course, more or less rules to help it to, let's say, follow the coding standards, and the tools that are available can, of course, support it. When we talk about code quality, it's not only the dedicated tools that will, of course, solve that for you. I mean, the code quality comes from different parts in your development. I mean, it starts, of course, with the compiler and the linker, reporting some possible problems during each build step. I mean, from typecasting and so on. But then, of course, you have the dedicated static analysis tools that will, of course, do a deeper investigation there. Let's say, design it to make sure that your source code is aligned to the coding standards. If you're using MISR-C or even other standards like CertiC or Common Witness Enumeration, that it's more like a collection of good programming practices. And of course, there are also some runtime solutions. Some bugs, they only pop up during runtime. So with some maybe instrumentation and some checking, like out of bounds can be detected in most situations. So what I mentioned on one of the first slides was the solutions for code quality, code analysis tools. I mean, from static analysis to some runtime tools. This is just to give you some additional information that aside of MISRA, you can also get access to CertiC, Common Witness Enumeration, as I said, collection of good programming practices. And that's part of CSTAT that is integrated into the IAR Embedded Workbench. And some of you, if you have had experience with MISR-C previously, you know it can be very tricky. And if you leave that step of verifying your source code or making it compliant with MISR-C after the project is done, you will get a lot of warnings or errors. You will get disappointed and will probably try to avoid it. So what we can recommend is that you make it become a practice. So if you use it on the day by day, I mean, you write your code, you compile it, you just test it quickly, you make it compliant on demand, of course, on the going. So that source code, once it gets tested later, it will be, of course, way more cleaner, better. So it's just a matter of becoming a practice. And then it's not painful, as I mentioned before. If you just enable it later, it might be the painful part of fixing everything that went wrong. So that's why we highly recommend the use of this kind of solutions. As CSTAT fully integrated, you can make it very easy. It's for the developer use day by day. And you get it fully integrated. You can generate reports. I will show that in practice. And on top, you can have some runtime analysis also, where you can do some bound checking, memory leaks, some good feedback on possible issues that might be in your source code before you go for the final testing, or even for some field testing, for example. So let's move on to the practical part here of my presentation. As we promised before, I want to do a demo for you. So I need to make sure I have the Embedded Workbench open for you. Again, maybe you're already familiar with the IAR Embedded Workbench. but this is the IDE from IAR systems. And I have a simple example here open. And some of the source code, of course, will be used later by Adam also on his practical part. So everything you need is, of course, part here of the IDE. But first of all, if I should get started here, I should definitely mention the number of devices that we, of course, support. It's, of course, a huge amount of devices. Last update was, of course, close to 10,000 devices that we support on the ARM. So if you look here on the list, we support all silicon vendors that are in the market with all cores. I mean, starting, for example, from all different cores, from the legacy ARM7, ARM9 cores to the latest Cortex, for example, R52 or even M33 and so on. So whatever you do in your project, this is mainly 50% of the configuration of your project, definitely. So from here, when you select the device or the core, the tool will know what kind of instructions should be generated. And when you do the debugging and, for example, use the simulator, you will know the memory ranges that are available, registers, peripherals, so that all will, of course, be known for the debugger. So device, it's the first thing, but also very important. To run debugging, you need to select the appropriate driver, and simulator is here listed as the first one. You can do a lot. You can even go to the next level by using some macros to, let's say, simulate some advanced hardware response. But of course, if you connect to the target directly, we have support for all the different probes, and the IAR solution is iJet that we have. From the settings, this is mainly what we need to do. Of course, the compiler from IAR, it's well known for code density and performance. So that, of course, depends a bit on which level of safety integrity level that you need to achieve. That in some cases, optimizations are not even allowed. But if you can do that, of course, you can best tune your application, and you can even choose some routines to be optimized for size, others for speed, that it's very flexible, very easy to use. So once I have the configurations ready here, I need to just cover the CStat that I wanted to explore a bit further. So you see the day-by-day use of it. So we support, of course, all the MISRA C standards, 30C common weak enumeration. And then we also have some standard checks that are good programming practices. For example, to avoid some arithmetic errors when you do comparison on floats and so on. That's all a part of it. You can, of course, disable what you don't want. I'm enabling everything here to make sure we are fully covered. So you can even get these settings out. You can see how many I'm using here from the total of checks available in my configuration. And what you can also do is actually you can export these settings, and it can become a standard in the company that you keep reusing this set of configurations, and later you just import it back. So you could say that for now everybody needs to follow this kind of rules from MISRA, from 30C, and it's mandatory for every project. What I can probably also say is that we are also very good here when it comes to false positives. So we are well known, or we got good feedback that compared to other tools, sometimes you get a lot of false positives and you spend a lot of time trying to figure out what was the issue. And it was not the issue, it was the tool that was detecting something that was not good. So you, of course, have it here. You should always have it enabled, of course. But sometimes people use 2 or 3 code analysis tools, so they want to make sure that what the other tool is catching gets similar here on our side. But once I select the checks I want to run, it's very straightforward. I can just run the analysis over the full project or over a specific file. And what I need to do here, I will just analyze here my full project, and it runs pretty quickly here. You even can run some parallel analysis. I mean, all the cores or threads from your PC can be used to optimize this. And as you can see, you get a report. You get, of course, the checks that are being triggered, the severity, the file. I mean, you can get some additional information if you select the double click on the check or the error or the message that you got. It will take you to the source code for easy navigation. But if the explanation is not good enough here, you can definitely just press F1 and sorry, I should get it here. And once you press F1, you get this context sensitive help here. And from this warning, that's the message that was generated, you'll get information about severity, certainty, and the kind of coding standards that have been triggered. But in my opinion, best of all is that you get a code example. So it gives you some hint on, let's say, bad code and good code, how to solve that or run it in a better way. So this is a really good reference to help you when making your source code, let's say, compliant with specific coding standards like MISR-C or CertiC, for example. This can be very helpful. And of course, you can also filter it by severity. You can filter it by message. If you check the documentation, it's very well detailed. You'll get additional information about the checks, also some additional reference on the examples. But also very important when you are working with safety critical solutions or applications, you probably need to generate some reports, and that you can also do here in a very easy way. So mainly what you can do here is run the report, and then it will tell you when the analysis was executed, how many files have been analyzed, functions, total messages. What would also appear here, and that happens sometimes, that in order to get rid of a specific message that gets triggered, you end up suppressing it. So that's not the right way to solve it, but if you do that, it will be mainly documented here too. So what I'm saying is that to be compliant with MISR-C, if you suppress a specific warning, you need to make sure that you document it, that you document that you tested it, that it's working according to what it's specified. Then you can still be compliant with MISR-C if you end up needing to disable one check order. So if you go down here, you can have it by file, for example. So if I just click here, I get the number of checks that have been triggered here on this specific case. So now I'm done here with making sure that the code quality it's enforced here in my application, and I selected the simulator before. And as I said, once you have the device, it will know exactly what's on the other side. And mainly what you can do, as I said, you can connect here to the debug session. And then, of course, everything that is available will appear first here under the view option to watch into memory, registers, for example. You can navigate very straightforward here. If you look on specific registers, we could check here all peripherals or what we want to investigate here on the memory. If you just type some symbol, it will take you to that address. So you have full control from stepping in, stepping out, running the application. And as I said, if you want to reproduce some good advanced hardware response, you can even use macros for that purpose. And we have good examples for that available too. So this is now the practical demo that I wanted to run from my side. And now I'm giving the session back to Adam. Adam will be able now to show us how the flow continues here on the unit testing part.
Thanks, Rafael. That was great. So hopefully you're now viewing my screen. I've got the same IAR Embedded Workbench project open. I've got a few slides. Cantata allows users to accelerate their testing to achieve standards compliance. I don't want to spend too much of my time inside PowerPoint today, so I'll very quickly run through a few slides to give you some background to the main features that I showed during the live demonstration section. I believe I've got 15 to 20 minutes, and after that we can take any questions that arise. If we don't get to your questions, like Georgette said, we will contact you directly after the session. Before we start, it's worth stating that Cantata, like Embedded Workbench, is independently certified as suitable for use to achieve the highest SIL for all the main functional safety standards, also by SGS TÜV. So this is a representation of the V model development lifecycle, which I'm sure you've all seen before. On the left, we've got the various levels of documentation and requirements, and on the right, the associated tests that fit with each stage. Cantata offers most at the dynamic unit and integration testing stages, and we also support some higher levels of testing. Once you've decomposed your design into code, the first thing you may wish to do before testing is to assess the code statically using a tool such as Rafael showed, the CStat inside IAR Embedded Workbench. After you do this, you should move on to dynamically proving that the code units do what you intended them to do, or what the design stated they should do. The most critical testing stages to get right are the dynamic unit and integration testing, before you move on to the higher levels. Throughout each testing phase, we should also ask, is the code tested enough? And this can be done by monitoring 3 types of coverage: code, test, and requirements. So test tools need to work well with other tools in your development tool chain. Cantata can be easily configured for a target platform with a built-in capability for unlimited target deployments. Dynamic tests with Cantata can be automatically synchronized with static analysis tools, so code changes that you make can be verified by both the dynamic testing and the static analysis techniques. We have Eclipse plugins, command line interface, and various file input outputs, which makes integrating Cantata with other development tools and IDEs easy, such as those from IAR, obviously, but also vendors such as Green Hills, Wind River, Carl, QNX, and so on. Automation is the key benefit of any tool, but it has to be flexible. Cantata's automatic test generation delivers a complete framework of structured tests for flexible approaches, unit integration, black and white box, with both GUI, graphical user interface, and code test editing options. Autotest, a feature of Cantata, generates complete passing test cases automatically, and I'll quickly show that in the demonstration. Tests developed in our GUI can be automatically regression run via makefiles that Cantata generates alongside the tests. Controlling interaction of code and tests with the rest of the system means not just simulation, but interception and use of real calls with different behavior each time the call is made. Cantata automatically generates simulations and interceptions for calls made by the code under test. Programmable instances with automated checks on parameters allow different behavior each time a call is made, and can additionally include any C or C++ code to add further behavior. Flexible call sequences in each test case can verify the exact order in which these calls are made. Integrated coverage is needed to avoid separate manual review activity. Data needs to enable diagnostics at every stage or run, and it helps you optimize test sets. Cantata makes pinpoint analysis easy with standard compliance rule sets, drill down filtered views of coverage from whole projects down to individual code syntax for all the industry standards. The report generated contains all coverage data as well as the dynamic test results. Finally, automatic coverage optimization identifies any redundant test vectors, and this can help with the selection of suitable input combinations. The style of Cantata test generation is determined by various tool preferences and options. The source code is compiled with Cantata enabled to parse it and store detailed information in internal files. The user selects what source files to test via the user interface or command line and Cantata. Using the tool preferences and options and the auto test algorithm, if you've selected that, Cantata generates test scripts in C or C++ and a makefile build system. And if you've implemented auto test, you also get a generation report. Cantata unit or integration tests are built and run as an executable. The software under test and any external objects and other library code is built with the Cantata test script, pulling in the necessary Cantata library code, which helps keep the test scripts clear of clutter and easily readable. If code coverage or testability instrumentation is used, a copy of the source code is taken at compile time, and a test executable for the target platform is built and run. This is done within supported build IDEs or under the control of the Cantata makefiles. And this produces the various results on the development host in various formats for analysis, and also raw ASCII text results, which are definitive for any certification evidence requirements. So that was a very quick splash through a few PowerPoint slides. I'll now switch into the products and we'll have a go at building up a test harness in real time. So my starting point is the IAR Embedded Workbench project. And as Rafael says, we've already loaded in some sample pieces of code. So I'm going to focus my attention on these two files here. We've got one called temperature monitor.c and one called temperature conversions.c. Now, the idea of these pieces of code is that we have a box of electronics that contains both a fan and a temperature sensor. And what we're trying to do is read in the values from that temperature sensor and maybe increase the speed of our cooling fan or get our electronics to shut down if the temperature exceeds known limits. So we've got this monitor temperature function here, which makes an external call to a sensor reading utility therm get reading. And then we've got this if statement with 3 branches that compares the sensor value against some recommended temperatures, and then we've got the desired behavior being called. We've also got in this file a function to write to a log what's going on, and in our temperature conversions we've got a switch between Celsius and Fahrenheit, Fahrenheit to Celsius, and our logging functionality. So it's quite a nice, neat, contained example that contains some interesting but easy to use code for demonstration purposes. So at this point, I don't have any test framework. All I've got is the software under test. So the first thing I'm going to want to do is build up a testing project to wrap around this piece of code. So I'm going to switch to the my Eclipse IDE. Cantata is built on Eclipse. It's a full code editor with some useful functionalities, but with the added Cantata plugins, you get some useful testing functionality built in. So you can see I've got a completely empty project here. The first thing I'm going to do is create a new testing project in this, and I'm going to point Cantata at the directory of code that contains the IAR Embedded Workbench project. So in demo IAR test, I'll just show you here, we've got our embedded workbench project and our collection of source files that we're going to be testing. So I point the tool at that directory, hit detect, and Cantata will analyze the files that it discovers at that location and determine the build system that's being used. It's automatically selected IAR correctly there. And also it selects the suitable deployment or kind of build system to be able to compile and execute that code. So in this case, we're compiling using the ARM compiler from IAR, and we're going to be running our test binaries inside the CSIM simulator. So I hit finish at this point, and we'll see down in the console output, Cantata do a test build of what it's finding at that location. So it's using the IAR build tools just to make sure that the project is compilable. It's scanning any external dependencies that that project may have, things like extra header files, maybe defines that have been set, and it's configuring our test project to match what it's seen at that location. And I can expand this out now, and we can see that we've got our collection of files imported. So for testing, we kind of want to hide away some of this clutter, so I can switch to our Test Explorer view. And now we're presented with the source files for testing our software under test. At the moment, our test node is empty. We haven't set up any test cases yet. So the very first thing to do is to highlight the source files containing the code we wish to test and generate a test script around that. So I'm going to generate a test script, let's call it test.c, and I'm interested in monitoring the code coverage that I achieve when I run my tests. So I can select from a number of built-in rule sets that cover the main functional safety standards. So we've got ISO 26262, DR178C, and so on. For this demo, I'm just going to choose something more straightforward, easily to understand. We're going to look for 100% statement and decision coverage across those files. On the next screen, we're presented with all the external calls that software under test makes. So we've got calls here to things like therm-git reading, which I mentioned before, our external function which reads data from a sensor. Now that isn't part of the software under test, that function. So what we're doing is creating a piece of stub code, a dummy routine to enable the software under test to build and compile. And we can use this stub routine to feed in some sample test data that would come from that sensor reading. The calls which have wrap next to them, this is useful functionality from Cantata that allows you to jump into the execution flow at the point that your calls are being made. So these wrapped functions are actually in the software under test. We've got our switch between Celsius and Fahrenheit, and what Cantata enables us to do is a kind of an advanced find and replace on calls to those functions, so that we can jump in, manipulate and monitor the data that's being passed on around in those calls, and also check on the values that are being passed back. So I hit finish there, and Cantata gets to work building our test framework for us. So we've got a number of things that have been generated. We've got this test script. And something that's fairly unique to Cantata is that its test scripts are pure C or C++ code, so that your testers and developers can really see what's going on kind of under the hood. These test scripts are well commented and structured. At the top, we've got the various external dependencies on the headers being defined. We've got a section for adding our test cases, our test vectors. And at the bottom, we've got our call interface control section. So these are our dummy functions for things that aren't in the software under test, but also we've got our wrapper functions, so our advanced find and replace utilities for kind of jumping in and controlling our behavior there. So let's go back and pick one of these functions to build some test cases around. I'm going to pick this monitor temperature. It's got a few different branches that we want to execute. And I'm going to tell Cantata to add some test cases specifically for that. So choose add test case. We can see we've got a selection of functions that are in the software under test to choose from. I'm going to choose monitor temperature, and I'm going to select the auto test functionality. I click go, and Cantata does a path analysis over that function to determine what test data is required to try and achieve maximum coverage. So we can see we've generated 3 test cases. These test cases have a nice English description, so we can really kind of see what the tests are doing and why that test case is there. And at this point, we should be able to run those tests. So I'm going to hit run. And down here in the console output, you can see the IAR compiler being called over these files, and it's linking, creating a test executable, loading it into the CSPI simulator, capturing the output from that test run, and loading results files back into the user interface. So we can now see this start to light up. We've got 3 passing test cases. I can expand this further and get more detail for that test run. And down here, you can see a bar graph start to appear. And this is an indication as to the amount of coverage that we're achieving over that file. So we've tested one function. I can drill down a bit further into temperature monitor. We can see our monitor temperature function has reached 85% statement coverage there. If I want to get even more detail, I can load up our coverage viewer at the code level, and I can see that the lines in green have been fully covered by our test cases. We've not managed to reach the lines in red, and the lines in yellowy orange are partially covered. So I can get a bit more detail on those. And for instance, this else statement that I've just selected, we've executed that twice down the false branch, but never down the true branch. So you can see that there's a limitation to our testing here. We've not managed to reach part of that code. If I just jump back into the code and let's have a look at that a bit more closely, I think there could possibly be a kind of mishap in the way that this else if branch has been constructed. So we're taking a reading from a sensor at this point. We're doing an initial comparison against recommended max temperature, which is 60 there. And then the next branch is doing a comparison against 80. So because of the logic in this flow, we're never going to be able to reach this element. So this is unreachable code, and Cantata has identified that by showing that it's unreachable and not being able to find a test vector for it. So let's try and quickly fix that. I'm going to switch back to the embedded workbench view, and I can just quickly change the order of these elements here. So now we've got the check for the worst condition first before we go into the kind of less serious condition second. Make a save here, go back to my testing project. You can see that that has immediately taken effect. We've got critical shutdown kind of as the first thing. So that code change that I made in the embedded workbench has been brought transparently through into our testing project. So let's clear this test run and get rid of our test data so that we can try running again. And we've made a slight change to our software under test, but we've not changed our test cases. So let's see what happens here. So again, we're compiling with the IAR ARMS compiler, running through the CSPI simulator and pulling back out the results. It's quite a useful feature being able to run in the pure simulator, because you're giving the software under test the kind of as close to real life environment during its execution as possible. So if I load up the coverage now, we can see our trigger critical shutdown has jumped to the top, but we're still not going into that. We need an extra test vector to be able to execute that line of code. So let's go back to our add test case selection. Again, run auto test over that. And again, we're doing a path analysis now over the change code. And we can see that we've got 4 additional test cases generated. So our initial check, we had 3, and now we've got 4. And I can see that the last one here has been added to solve the case where the temperature critical has been hit. So let's again clear this test run and see what happens with our additional test cases. You see me kind of adding test cases and recompiling and rerunning, and this is kind of typical workflow that we see when people are using the tool, being able to jump backwards and forwards, run different test runs with different test cases, and actually dive in and see what coverage that we're achieving is useful functionality. It's very easy to work with. So just wait for this simulator to run and load the results back in. And now we can see that we've got 7 passing test vectors. We can see that we've got full coverage now, 100% statement coverage over our monitor temperature. I can view the coverage view. Everything is green. So we've got passing test cases there, but we've got duplicated test vectors. So we've got test cases which aren't necessary to achieve that level of coverage. And something that is quite key when you're kind of optimizing your tests is to make sure that you've got kind of the minimum viable number of test cases. Just helps with maintainability, helps the tester understand what's going on. So with Cantata, we've got a built-in test case optimization routine, and I can click that and it's identified the test cases which achieve the same results from a coverage point of view. So that's great. I just wanted to, before I leave it there, just show you some of the functionality that we're setting up. So we're generating not only the test script, so the C compilable test script, but we're also generating a complete build system. So I can jump into the Cantata directory that's being created, and you can see that we've got kind of make files in here, as well as all the output routines. So everything is nicely self-contained, and that enables you to build up a regression test suite that you can execute maybe in a command line mode. So let's just clean away our tests here and rerun. And you can see exactly the same build process happening on the command line as we saw in the IDE. And again, this works well in a continuous integration environment. You can rerun these regression tests, maybe using something like Jenkins to get your tests running as frequently as possible. So I think I'm running out of time there, but hopefully that kind of quickly shows you the power of the tool. We've very quickly fully tested a function from our software under test. We've built a complete test framework from nothing, and something that would typically take a tester maybe a day or more to kind of figure out and create this test harness, we've done in the course of a 10 or 15 minute demo. So one final thing to show are the results that we've got for certification. So everything comes through into an ASCII text file, which has full details as to the data that's being passed in and coming out, and also the coverage details that we've obtained. We've also got a HTML summary showing across our entire software under test what the total coverage we've got. Any test passes and fails are highlighted there. And also we can view the output from CSTAT from IAR directly in this interface. So if CSTAT is picking up any static problems, we can start to address those inside our testing project. So let me jump back now to PowerPoint, and I think Rafael has got a summary slide just to round things off.
Good, thank you, Adam. Very good. So to summarize, of course, what we want to help you is, of course, that the pre-qualified or certified tools can ease your certification efforts. And also very important that safety starts with good code quality. So there are tools to help you on that. Of course, if it's integrated, it's way easier. But the main message, of course, is that IAR Embedded Workbench and Cantata from QA will, of course, help you to ensure quality, reliability, efficiency in your embedded application. And you will, of course, be able to comply with testing requirements of software safety standards to implement the best practice. So that's a perfect fit, perfect flow when you go from the development to the unit testing. Yes.
That's great. So I think we've got a few minutes for a quick Q&A session. Before we go on to that, I just wanted to put up this slide that has email addresses to reach both myself and Rafael. So if you've got any questions that come up after this, or we've not got to your question, you're welcome to contact us directly. So Georgia, have you been monitoring the questions as they've been coming in?
Absolutely. Thank you, Adam and Rafael, for this interesting presentation. As a reminder to our audience, if you have any questions, please type them in the question box on the right-hand side of the screen. So the first question I see coming through is there an evaluation available for existing customers?
Yes, well, not only existing customers, but new customers as well. We provide a supported evaluation version, which allows you to try all the features of Cantata in a 30-day period. And if you want to take up that offer, you can visit our website and hit Start Trial, or you're welcome to email directly. And Rafael, I think on the IAR side, you offer something similar?
Yes, definitely. I mean, if you go to IAR.com, you can download the evaluation version, and it's available for different architectures. That's the way to get started. IAR.com, you can download the evaluation. Yeah?
Thank you for those answers. Unfortunately, it seems that we have reached the end of our meeting. If we did not have time to answer your questions during this webinar, we will contact you directly with the answer. Thank you very much for your attendance.
Thanks, everyone.
Thank you.